Good morning, happy kids. This is Mrs.Z. Today we're going to talk about ZERN Math Student Edition, Grade 5, Module 4, Lesson 5, Problem Sets. It's Mrs.Z, and today is January 12th, 25th. Okay. First problem that we have is said a total of 2 yards of fabric is used to make 5 identical pillows. How much fabric is used for each pillow? So very important is to know what do we have. So your idea should think, oh, what do I have? I have 2 yards. So and what I need to do with that is I need to make 5 identical pillows. What that means that I have to divide or share 2 yards into 5 pieces. So if we take the fraction representation, we can say, oh, that's 2 yards divided into 5 pillows. Very important is that you label each. So this is 2 yards, and then this is P for pillows. So when I think that the 5th grade students need to know that fraction line is division line. 2 divided into 5. Okay, we'll come back to that, but we will find the answer by drawing our number line today. So if I need 2 yards, let's pretend that these 2 yards are my 10 centimeters. So I'm going to go and draw 10 centimeters and 5 centimeters each yard. So this is how long is 1 yard. And this is 1 more yard. So that's 2 yards. Now, we needed to think about, we needed 5 identical pillows. So I'm going to divide each yard into fifths. So each yard will represent 5/5 now. So if I take that, then I look, okay, it says here that each pillow will take 2/5 of the yard. So I can say, okay, if this is 0/5, this is 1/5, 2/5, 3/5, 4/5, and 5/5 would be my, but I have 2 yards, so I have 6/5. I have 7/5. I have 8/5. And this piece is 9/5. And finally, 2, this is 0, this is 1, this is 2 yards. 2 yards is 10/5. Now I can think about that each pillow will represent 2/5 of this. So I can say, okay, this much material I need for 1 pillow. You can make it even like this. Okay, that's 1. And then I can use another highlighter like pink. These 2/5 will represent another pillow. And then these 2/5 will represent my 3rd pillow. These 2/5 will represent my 3rd pillow. And then the last pillow is this one here. So I will make 5 pillows, but each pillow will need 2/5 of the yard. 2/5 of the yard. So if 2/5 of the yard, so 2/5, you can change 2 divided by 5 is 2 to you can change from the fraction to division representation, or from division representation to fraction. Now we need to answer in a word. How much fabric is used for each pillow? 2/5 of the fabric is used for each pillow. Okay. That would be a problem 1 in a set. Next. Okay, that would be number 1. Number 2. Okay, an ice cream shop uses 4 pints of ice cream to make 6 sundaes. How many pints of ice cream are used for each sundae? So if I would like to do that, I look my, so what I have 4 pints, and I need to make 6 sundaes. So I have less than, if I have 6 pints, I can make, and each sundae is made of 6. I could make that one sundae will be 6 sundaes, but I have less pints and I need to make more sundaes. So this time I'm going to use an area model. So again, I'm going to start with what I have. I have 4 pints, and I need to divide that into 6 sundaes. Okay, 4 pints divided by 6 sundaes, or 4 divided by 6. Okay. At this time, I'm going to use area model. So if I pretend that this 12 are my 4 pints, I'm going to write them like this right here. Okay. There is, I'm going to have 12 centimeter to be, but I will have 3. Okay. Needle represents 4 pints. So if I take 12 centimeters and I measure that 1 pint is like 3 centimeters, then it will be easy to make my 6th, because my goal is to make a 6th. So, and then I'm going to draw my lines, and I'll take it 2 centimeters up. Okay, I'm going to take my ruler and make parallel lines. Okay, and I will have my area model. So now I can label. I can do my perpendicular lines to make my rectangles right there. Okay. So now I have 4 pints. That's 4 pints. Okay. So I needed to share that. So I know that if I take 4 pints and divide into 6, each ice cream will take 4/6 of a pint. So I can go and I can divide each pint into 6 pieces, but because of that, I can do this 1, 2, 3, 4, 5, 6. I have 5 lines. I make 6 pieces 1, 2, 3, 4, 5, 6. But then I also can think that 4, 6 could be simplified by combining these two pieces to make a thirds. So instead of doing sixths, I'm going to do thirds. So I can show you why. Because each of these little guys is a sixth. So I'm going to make a six so you will see. But the space of 4/6 is the same as 2/3. Okay, so if I do that, I can show you if you have 4/6, you can combine two pieces together, which we'll call, if you divide with the same number, denominator and numerator, you can make equivalent fraction. So if I divide 4 by 2, what number times 2 equals 4? It's 2. 2 times 2 is 4. What number times 2 equals 6? It's 3. 3 times 2 is 6. So if I combine, these are my 1/6 now. If I think 1/6, 1/6, 1/6, 1/6, 1/6, 1/6. If I combine 2/6, I will get I will get 1/3. But my portion is 2/3. So my Sunday will needed to have a 4/6. So 1, 2, 3, 4/6 will be one ice cream. So if I highlight that, this how much will be taken to make one ice cream. 4/6. 4/6 makes one ice cream. Also, we can say that is 2/3. This is 1/3. This is 2/3. Together, they make 2/3. So we can say 2/3 of the pint will make one ice cream, or we can say 4/6 will also make one sundae. But I just did 1 pint, so I have a 4 pint, so I have to keep dividing them into 6 equal pieces. I'm going to do the same thing on all my pints. So I will make sixths. And then when I take my parallel line, I can make it and make more precision my drawing. So right now I will, if you think about how ZERN does it, he think now 1 pint is 6/6. So if you think 4 times 6 is 24, you will have 24/6. And then 24/6 will divide it into groups of 4. So I'll see how many sundaes you will be able to make. What is 24 divided into 4? Okay. 4 pints of ice cream to make 6 sundaes. Okay, so each sundae was taking 4/6. So that would be 1 sundae, 2 sundaes, 3 sundaes, 4 sundaes, 5 sundaes, 6 sundaes. So 4/6. So if this is 2/5 that is left from 1. I'm going to just make divide how many. So 2, 4, 6. This was 2 and 2, 4, 6. This was 3. So if you think about 4 pints, this was 1, this was 2, this was 3, and this was 4 pints. Okay, so I have, when I make one sundae from 1 pint, I will have a 2, 6 left. So I'm going to use this 2/6 and I will divide another pint into 6 pieces. But then I will take only 2 of those and I will make another sundae. So let's see that could be the pink sundae. Okay. So now if I take another 4/6, that's another sundae. If I take another 4/6, 1/6, 2/6, 3/6, 4/6, that's fourth sundae. For 1, 2, 3, 4 sundae I already made. And I will take this 1/6, 2/6, 3/6, 4/6. That will be a fifth sundae. And then the sixth sundae is last 4/6. Okay. So how to start? We had 4 pints. And we need to make 6 sundaes. So that we need to share 4 pints with the 6 sundaes. So each pint, each sundae will give us 4/6. 4/6. We divide each pint into 6 pieces, and then we combine 4 equivalent pieces to make a sundae. So this was 1 sundae. This was the second sundae, third sundae, fourth sundae, fifth sundae, and sixth sundae. Each takes 4/6 to make. Each takes 4/6 to make. Okay, so how many pints of ice cream are used for each sundae? We need to answer the question in writing. For each sundae, okay, for each sundae, they used 4/6 of the pint. Pint. Okay, or we can say that they were using also 2/3 of the pint. So because if you think about that 1 pint is a 6, we'd prove that this is 1/3 and this is also 2/3. So 2/3 or 4/6 we can say that it was used to make 1 sundae. Okay, let me see. I hope that makes sense to you. Okay. An ice cream shop uses 6 bananas to make 4 identical sundaes. How many bananas are used in each sundae? Use a tape diagram to show your work. Okay, so now thinking about what do we have? We have 6 bananas. What do you have? It always goes on the top. So we have 6 bananas, and we need to make 4 sundaes. Dividing by 4. 6 divided by 4. Now, the numerator is greater than denominator. Right now, 4 pieces are enough to make one whole. So if I have 6 fourths, that means that I will use more than one banana to make a sundae. But let's make that clear how we can do it. 4 divided into 6. So if I take again a ruler, and we want us to do the type diagram, let's pretend we have 6 bananas. Okay. So I will take all that. I will take my longer. Yeah. So I will use 12 centimeters to make a long tape diagram. So each I need 6 bananas. So let me see if I can make 1, 2, 3, 4. Okay, 2, 4. 2 centimeter will be 1 banana. 1, 2, 3, 4, 5, 6. So now I have 6 bananas. 1 banana, 2, 3, 4, 5, 6. 6. So that's if we are using a tape diagram, we can make and represents in your ZERN. You're going to divide the rectangle into 6 equivalent pieces. Okay, so if each piece 1 banana, 1 banana, 1 banana, 1 banana. Okay, that is 6 bananas. But we needed to make 4 identical sundaes. So 4/6 will give us 4/6, 4, oh, 6 divided. You see, I made a mistake here. What did I do wrong? What do you think? What do you have is first. What you are sharing with is your second number that you are. So if I have a 6/4, I need to divide 6 divide into 4 pieces. So that tells me if I think about fractions, I can think, okay, this is 4/6. In the bottom number tells me how many pieces I need to have to make a whole. So if I take 4 from 6, I will make a whole. But then I will have 2/4 left, because if you bubble this, 6 is made of 4 plus 2. So now I decompose my fractions into 4/4 plus 2/4, and it tells me that 4/4 is same as 1 whole, and then 2/4, 2 is a half of 4, so that is also 1/2. Right there, I can tell you that 6/4 is the same as 1 whole and banana and 1/2 of a banana. So when I look my picture, I can see, okay, I'm going to change this bananas into halves. So I'm going to cut each banana into half. reason why I do that is I can use now each half to represent Sundays, but I need 3 halves to make a Sunday because 3 halves is 1 whole and 1 half. So this you can also think about the 3 halves would be the same as 6/4 equivalent, because when you think about 1 whole and 1/2 banana is 3 halves. 1 whole makes 2 halves, and then 1/2 that you had, that would be 3 halves. Or you can also say, if I cut this into 4 pieces, like into fourths, then I will have a 6/4 to make one Sunday. 6/4 of banana, which makes, yeah. So right now, if this is one banana, that's 2 halves. I know 1 whole and 1/2 will make me one Sunday. So if I take that, this is going to be one Sunday. Again, if I take another, take different highlighter. Let's see if I this one pink, maybe. Okay, I can take this half, and this half, and this half. That will make another Sunday. Again, I have 3 halves, or 2 halves makes a whole, and 1/2. That's another Sunday. One more Sunday. And I will take this 3 halves. I'll make a Sunday. So 3 half bananas makes one Sunday. And then last 3 halves will be make another Sunday. So if I do have 6 bananas, and each banana, it's not enough for a one Sunday. I have to think that 1 whole banana and half of the next banana will make a Sunday. So if I have 6 bananas, I can make 1, 2, 3, 4 Sundays. Okay, use type. How many bananas are used in each Sunday? In each Sunday, are used 6/4 of banana, or 3 halves, or 1 whole and 1/2 banana. Okay, in each Sunday are used 6/4 of bananas, or 3 half, or 1 and 1/2 banana. Okay, that would be the if you like to connect this with division, we can also use a standard algorithm to prove our answer. So let's see, if I needed to change a fraction into division, so I need to divide 6 into 4 pieces. What that tells me, I usually say crisscross applesauce, so kids don't know where to put when. So if I look 6 divide into 4, the 4 goes in the front, 6 goes under the bridge. So let's see if I use this. My group is 4, and I need to see how many fourths are in 6. There is only 1/4 in a 6. So that means 1 times 4 is 4. When I subtract, I got leftover 2. Now I do not have any more. I do not have any more numbers, so you can keep dividing to get the decimal, because it will be 1.5. Or we can say that this is leftover out of 4 pieces. So one answer could be A, for example. It would be one whole banana and 2 out of 4 left, or one whole banana and one half. Okay, both answers are equivalent, and that could be a one answer as a fraction. Show remainder. Another, if we want to continue dividing, we can think, okay, I'm going to use my decimal here. Now I'm going to share this leftover, which is 2. I'm going to add a 0 and bring down to 2. What it really means is that you have leftover of $2, and now you're making it in 20 dimes, 20 tenths. So you have left 2 holes, and now you're going to change the holes in 20 tenths. So how many fourths are in 20? Of course, you can keep adding 4 if you want to, or skip count by 4, but there is 5 fourths into 20. 4 times 5 is 20. When we subtract, we got 0. So our answer B could be also 1 and 5 tenths. Answer as a decimal. That's another way to think mathematically to prove this answer. Okay. I hope that you like this explanation, and this was Mrs. Z. I think we have more on the back. Let's see how it's gonna go. Okay. Julian has to read 4 articles for school. He has 8 nights to read them. He decided to read the same number of article each day. So he has to read 4 articles for school, and he has 8 nights. This is really important because it's kids very often go straight to 4, and they will say 4 divided into 8, or 8 nights divided into 4. So the question is what we have. We have 8 nights. We have 8 nights to share that into 4 articles. So, or 8 divided into 4, which right away you know that its answer is going to be 2. He will have 2 nights to read. So if this is 8 nights, in a 4 article, he will read 2 articles per night. How many articles we have to read per night? Because we can show that as into the if he has 8 nights, let's see, number line, open number line, so each centimeter is night. So 8 fourths. We can think about this if you wanted to make a smaller. We can say 8 fourths 8 divided by 4 equals 2. So what that means that if you have 8 nights, and you will need 2 nights, 0 nights, 1, 2, 3, 4, 5, 6, 7, 8. You will need 2 nights for one article. One article. And again, 2 nights, one more article. And then 2 nights, one more article. 2 nights, and he will read all articles there. Okay, so how many articles he have to read per night? He has to read 2 articles per. Oh, sorry. He has to read. Oh, sorry. So if it's one night, he needs to read half article per night. Half article per night. Or we can say he has 2 nights to read 1 article. In this case, you can think about whatever you like to put. If you like to see that 8 nights divided into 4 articles, this would be that 8 nights divided into 4 articles. Or if you think that 4 articles divided into 8 nights, so that would be the answer would be here. So that's kind of interesting question that you can see the both ways to figure it out. How many articles per night or how many nights per article, which is connected into 6th grade question. 6th grade curriculum kind of ratios. Okay, so what fraction of reading assignment will he read at each night? So that's actually we answered that each night he will read half of an article per night, but we can use that again. What fraction of reading assignment will he read each night? Each night he will read 1/2 of the reading each night he will read half of a reading assignment. Okay, let's see what is next question. Next question says that 40 students shared 5 pizza equally. 40 students share 5 pizza equally. How much pizza will each student receive? So 40 students shared 5 pizza. What they have 5 pizzas and sharing with 40 students. So what that means is that we can think each student will get 5/40ths of the pizza, Or if we think about simplifying the fractions, we know that 5 is divisible by 5 and 40 is divisible by 5. So equivalent fraction to 5/40 would be also 5 divided by 5 is 1, because 1 times 5 is 5. 40 divided by 5 is 8, because 8 times 5 is 40. So we can say that each student will get 1/8 of the pizza, or each student will have a 5/40 of the pizza. Okay. How much? How much pizza will each student receive? Each student will receive. Okay, 5/40 of, or 1/8 of pizza. A pizza, because it's one pizza is shared. 5 pizzas are shared with. So I can, if that is pretty much it. Okay. We can also show if we have circular model. Okay, that's it. Hold on, I want to show you a picture. Then I change my mind, but this will work. Okay, so how you can see it as a pictorial. So let's see if I have these 5 pizzas. Okay, I can divide them into 40 pieces, but when we can make 2, 4, 5, we can make simplified fractions. We can really think about 5 times what makes 40. 5 times what makes 40. So that is 8 pieces. So if we make 4 pieces, the pizza, if I cut each pizza into the half, I'll show you how you can make a half. Okay, now each pizza is in a half. Then now I'm gonna make each pizza into the fourth. So now I have a 5 times 4. I have 20 pieces. Now each fourth, when you divide that into half, will give you the 8. So if I go back and I have okay. So 5 pizzas dividing into 8 will give you a 40 pieces. So each student will get 1/8 of the pizza. 1/8. So how you can know it's you can serve 8 people from one pizza, and 1, 2, 3, 4, 5. 5 times 8 equals 40 students. And that's what we justified our answer, that each student will receive a 1/8 of the pizza. 1/8 of the pizza. Mhm. Thank you very much for listening. This was the student addition, lesson 5, set problems, and that this was Mrs.Z. Okay, goodbye.